Here's the next example of Riemann sums, okay? What we're going to do is we're going to approximate the area underneath the curve 1 over x from x equals 1 to x equals 2 using 4 rectangles. So the computation here is going to be a little bit easier because we don't have 6 rectangles to do. So we're not going to have 6 points in our area formula. Okay, so let's first go ahead and draw a picture of what this looks like. So right here is 0, right there's 1, right there's 2, 3. See, there's 1. So at 1, you're at 1. At 2, you're at 1/2. And then at 3, let's see, you're at 1/3. So the graph looks something like that. Okay? I just drew this piece over here going to 3 just for a little extra so you can see the curve a little more. This goes up to infinity, and this would keep actually going off, getting closer and closer to 0. Now, it wants us to find the area right there, okay? The function, this is 1 over x, so right here is f of x equals 1 over x from x equals 1 to x equals 2. Now, what we're going to do is we're going to split this interval into 4 subintervals, okay? So we're going to split it into 4 rectangles. All of them are going to have the same size, delta x. Delta x, if you remember, is b minus a divided by n. 4 rectangles, that makes our n equal to 4. So 2, here's our b, here's our a. 2 minus 1 divided by 4 is 1/4. Okay, so that's our delta x. So let me go ahead and I'm going to redraw this picture, blow it up a little bit more, just go from 1 to 2 so we could better draw our rectangles. Okay. So we have our delta x is 1/4. You could put 0.25 if you like decimals better. We'll do decimals here. Alright, so let's see. Here's the graph. Let's see. Here's 0. There's 1. There's 2. 1. Okay, so that is the shape, the area of this shape we're going to find, okay? Now, we're going to split it up into 4 equal intervals. Every interval is going to have a width of 0.25. So, splitting this up into 4 equal parts, you start at 1. If I add delta x to it, 1 plus 0.25 is 1.25. Adding another 0.25, you get 0.5. Adding another 0.5, you get 0.75. Okay? So, all these numbers are going to end up being the endpoints for our rectangles. Okay? So let's go ahead and do a left endpoint. So if we are doing a left endpoint approximation, when I start over here and then I look at this pair of x values and I want to pick the one on the left, okay? So I go all the way up to my function at that x value, and then I just go over and make a rectangle with my next x value. If you notice, this time the area above here, I'm over counting some area. Okay, so the left endpoint approximation is going to give us an overestimate this time, whereas in the previous example, it was an underestimate. So as you can see, the left endpoint approximation is not always an is always an underestimate. It can be an overestimate. It really depends on your function and where you're looking at your function, okay? So now I move on to the next pair of tick marks, x values, and I pick the one on the left. So I go all the way up to the function, and then I go over and draw a rectangle to the next x value. Do the same thing here. I pick the one on the left, go up to the function. There we go. This one over here on the left, go over, and there we go. We have our 4 rectangles. So the area of this one plus the area of this one plus the area of this one plus the area of this one is going to give me the approximate area for the actual shape I'm looking for. So the area here, remember delta x is the same throughout the entire thing, so we can factor out a delta x times f of x1 plus f of x2 plus f of x3 plus f of x4. This is the width of our rectangles down here. Each one of these widths right here is a delta x. And then over here, these are the heights. These are the f of x of i's. F of x1, f of x2, f of x3. So all we're doing is computing the area of each rectangle and then adding them all up. So delta x is 0.25 times f of, now we are choosing the left endpoint. We are doing a left endpoint approximation. So out of these two for this rectangle, we chose the 1 right here. So this is f of 1 plus f of, now for the second rectangle, first rectangle, second rectangle, out of these two, we pick the left endpoint. So f of 1.25 plus f of, out of these two, we pick the left endpoint, which is 1.5, plus f of, and then we pick the left one out of here, which is 1.75. And now we go ahead and compute this number on the calculator. Okay, so I entered in my y1, 1 over x, my function. So now what I'm going to type in on the calculator is 0.25 times, so 0.25 times with the parenthesis, delta x, 0.25 with the parenthesis, and now I'm going to use my function values. So vars, go over to y vars, function y1 of 1. So there's the first piece, y1 of 1, that's this f1 right here. Plus, I'm going to do it again, vars, y vars, function y1 of 1.25. Do it again. And you put 1.5. And then lastly, do it one more time, y1 of 1.75. Then close the parentheses, hit enter. I get 0.7595. That was the left approximation, left endpoint approximation. Remember, we counted this extra area up here in each rectangle, so this is the over estimate. Okay, we just found an overestimate. So we don't need this anymore. We're still going to keep this. What's going to change is just these function values when we do the right endpoint estimate. So left endpoint approximation, it gave us the area was equal to 0.7595. Okay, so next we're going to find the right endpoint approximation. Area is going to be something. Got to figure it out. Okay, so all we're going to do is we're going to draw the rectangles using the right endpoint this time rather than the left endpoint. I'm just going to redraw it. Where's my... Like that. Okay, so now when we're looking at this first interval here, I want to go ahead and pick the right endpoint. I'm going to go up to the graph. I'm going to go back, and there's my first rectangle. As you can see, there's area O right there that I'm not counting for. So therefore, this should be an underestimate. So let me get rid of some of this. Now we are doing a right endpoint estimate. So do the same thing. We choose the one on the right, go up, over. Choose the one on the right, go up, over. Choose the one on the right, go up, over. So there are our 4 rectangles that we are going to pick. So the process is very much the same. The area is still exactly this. The only thing that changes here are the function values. Okay. So for the first rectangle, this height right here is the function value at 1.25. So 1.25 is going to go there. Then over in this rectangle, the height is 1.5. Use the right endpoint for this height of this rectangle, 1.5. And then out of these two, for this third rectangle, you use the right endpoint, so 1.75. And then you use the 2 for the very last endpoint. So again, plugging this in on the calculator in a very similar way, you get 0.7095. So 0.7095. Okay, so what this is saying is that using 4 rectangles to approximate the area underneath this curve between 1 and 2, we got, and this was an overestimate. This one is an underestimate. So we know for a fact that the actual area underneath this curve must be between 0.75 and 0.70. Okay? Now let's see if we could do a little bit better. Let's go ahead and find the midpoint approximation. You should expect the midpoint approximation to be somewhere between these two. Okay? Okay, let me get rid of some things. Right here, right here, right here, there, right there. Okay. So we need the midpoints. Right there, right there, right there. I'm missing my black tip marks. There, right there. Over a bit. Okay, we need those midpoints because then we're gonna find those function values right there. Okay. So, let's see. The midpoint between here and here. The way to do it is you add the 2 values and then you divide by 2. 1.25 plus 1 is 2.25. 2.25 divided by 2 1.125. So that's what's going to go in here, 1.125 for the midpoint approximation. Now for this one, you could do the same thing. 1.5 plus 1.25 is 2.75. 2.75 divided by 2 is 1.375. So 1.375 is the height of the next rectangle. Do it for the next one. 1.5 plus 1.75 is 3.25. 3.25 divided by 2 is 1.625. Okay, we got one more. 2 plus 1.75 is 3.75. 3.75 divided by 2 3.75. 1.875. So now we have all the midpoints of the interval. See, this is 1.625, this is 1.875. So now go ahead and repeat the process. Plug this all in on your calculator. And let's see what we get. So 1.125, y1 of 1.375, 625. Let's see. I got an answer 0.6912. 0.6912. Let's see. I can tell you the actual area of this curve. Give me a second. Equals 0.6931. This is the actual area. I did get this from the calculator. So what I think I may have done, I will go back and check it and let you know if I miscalculated something. I may have misinputted this on the calculator because it should have been an underestimate. But as you see, the process throughout this whole thing, the calculating Riemann sums, is very procedural, okay? All you have to do is determine, are you using the right endpoint, left endpoint, or the midpoint? Now again, the midpoint is very useful because it gives you a really close answer to the actual. As you see, this is the actual area from 1 to 2. Here is using the midpoint. Here was using left end, which should have been an overestimate. Here's using the right end, which should have been an underestimate. So again, I think I mistyped something in my calculator when doing that. Now you should go ahead and try the next problem. It's the same thing, estimate the area under the graph, but it's 1 plus x squared from -1 to 2. Okay, so you're using 4 rectangles, so very similar to this problem, and you got to do it for right, left, and the midpoint.